let's solve y double prime minus 9y equals e to the 3x. Okay, and if you want, this could be 7e to the 3x or whatever constant you want to put in front. But I just want to do a constant times e to the 3x. Now, when we look at the complementary solution, we're going to end up with c1e to the 3x plus c2e to the negative 3x, because if this right side is 0, let me just zoom in on this part here. So if the right side is 0, then you're going to end up with the equation r squared minus 9 is 0, r is going to be plus or minus 3, and there's your solutions if r is plus or minus 3. Okay, and so that's the complementary solution. Next, we're going to try and find the particular solution, and a good guess would be a constant times e to the 3x. It turns out that if we take the first derivative, we'll get 3a e to the 3x. If we take a second derivative, that's going to be 9a e to the 3x. And when we do that, what we're going to end up with is, so if we take this and plug it back into our equation up top, we're going to end up with y double prime. So this leads us to look at the second derivative, minus 9 times the original function, so minus 9a e to the 3x, equals 7 e to the 3x. And this is even worse than the trig and sine and cosine example, because this is never going to have a solution ever, right? Because there's no constant that we can pick that's not going to make that left side 0. It's always going to be 0 no matter what a we pick. So this tells us that we really messed up our particular solution. Even though that was a good first guess, we need to try again. The problem, as you might guess, is that this can't be the particular solution, because the particular solution is supposed to be the solution to this equation with the non-homogeneous part. But if you think about e to the 3x, 3 was one of the roots to the characteristic equation, meaning that a constant times e to the 3x appears in the complementary solution. And therefore, this function's going to satisfy y double prime minus 9y equals 0, as we saw. That's why the left side was 0. So what we have to do is we have to amend our guess to include the fact that e to the 3x already appears in the complementary solution. And so what we're going to do then, let's put a big x through our work here. But what we're going to do is we're going to guess our particular solution maybe is going to be ax e to the 3x. Okay, and so this is just like when you had repeated roots and you had to put an x in front to get a linearly independent solution. Same idea. So we're going to have an a times x e to the 3x. Now, if we do this, then finding the first and second derivative, we're just going to use the usual product rule. So we'll have, we can factor out the a if you like. And then if we differentiate x e to the 3x, we're going to get the derivative of the first times the second, plus the derivative of the second times the first. And this will be a times the quantity 1 plus 3x e to the 3x. And then our second derivative, we can again factor out the a, and we're going to get the derivative of the first times the second, plus the derivative of the second times the first. And then we can simplify everything, and this will give us a times, let's see, we're going to end up with 3 plus 3 plus 9x e to the 3x. So that's our first and second derivative. That should be a straightforward calculation for us. But now we're going to take these quantities and plug them back into our original equation. We were looking at y double prime minus 9y equals 7e to the 3x. So let's look at y double prime. So it's a, in our case it's a times 6 plus 9x e to the 3x. And I mean y sub p double prime. Minus 9y sub p. So minus 9a e to the 3x. That's going to be equal to 7 e to the 3x. And now at least there's a chance, right? Now at least there's an opportunity for this to go well. So minus 9 a e to the 3x. Something is wrong. I wrote down the wrong particular function. was going to say this doesn't work out again, but that's because I wrote down the wrong thing. This should be 9y sub p. Y sub p is ax e to the 3x. And now everything is fine. Okay, good. So now everything is fine. So what's going to happen is, so our equation is going to become, we're going to have 6a e to the 3x plus 9ax e to the 3x minus 9ax e to the 3x equals 7 e to the 3x. And that tells us that 6a is equal to 7, and therefore a is 6/7. So it turns out that our particular solution is going to be 6/7 x e to the 3x, don't forget the x, and therefore our general solution, y, is going to be the complementary solution, which was c1 e to the 3x plus c2 e to the negative 3x plus the particular solution, 6/7 x e to the 3x. Okay, and so that's how we'll handle what happens when our non-homogeneous function appears in the complementary solution.